Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video lesson, I'm going to talk about CAI 5070 past paper, and I have selected this time October-November 2022, and the paper is 21. The paper is about theory. It is paper 2. Let's continue the paper. Section A, answer all the questions in this section in the spaces provided. The total mark for this section is 45. Question number 1. The diagram shows part of the periodic table. The part of the periodic table is shown here. Answer the following questions using only the symbols of the elements in the diagram. Each symbol may be used once, more than once, or not at all. Give the symbol of the element that is a catalyst in the hydrogenation of alkenes. You have only one element which is used as catalyst in the hydrogenation of alkenes, and that is nickel. So I will write Ni here. B is extracted by electrolysis of its oxide dissolved in cryolite. Cryolite is added to oxide to get aluminum from its oxide. So oxide should be of aluminium. So I will write Al here. C is a metal below copper in the reactivity series. The only metal we can see here which is below in the reactivity series of copper is Ag. Ag is silver. D is a gas used in welding. Oxygen is used in welding, so you write the symbol O here. E forms an ion with a charge of -1. We have only one element which is forming -1 ion after gaining one electron, so we write the symbol Cl. Question number 2, carbon dioxide is a gas at room temperature. A1, draw a dot and cross diagram to show the arrangement of electrons in a carbon dioxide molecule. Show only the outer shell electrons. First of all, you should know the formula of carbon dioxide. Carbon belongs to group 4. So the valency of carbon will be ±4. And oxygen belongs to group 6. The valency of oxygen will be -2. So ignore their charges. You will get 4 and 2. Now these numbers will be simplified. Both will be divided by 2. And you will get 2 here, 1 here. These subscripts will be exchanged. And in the end, you will get the formula CO2. Now I'm showing the key on the right hand side. For carbon, I'm using dot. For oxygen, I'm using cross. There'll be one carbon atom and 2 oxygen atom. So that carbon atom must be in the middle. This is carbon and 2 oxygen atom will be attached and on right hand side and left hand side. Now I'm showing the valence electrons for carbon. There are 4 valence electrons for carbon. So it will be 1, 2, 3, 4. Oxygen belongs to group 6. So it must have 6 valence electrons. In order to complete its valence shell, they will share 2 of their valence electrons with 2 electrons of carbon atom. So you will get this 1, 2, 3, 4, 5, 6. On right hand side, 1, 2, 3, 4, 5, 6. Question number 2. Describe the motion and separation of the particles in a gas. You have to write the motion and separation of particles in a gas state. Remember, in gas state, the particles are far away and they are moving randomly in all directions. So you have fast or random movement. Fast or random. Now, if we'll talk about the separation, they are far apart. Part B. The main processes in the carbon cycle are combustion, respiration, and photosynthesis. Number one, name the products of photosynthesis. We know that during photosynthesis, plant takes up carbon dioxide and water from the air, and in the presence of sunlight, it produces two products. One is oxygen gas, and other is its food, which is glucose. Number two, some of the reactions in photosynthesis involve enzymes. State the meaning of the term enzyme. Enzymes are biological catalysts, or you can even write catalysts in organisms. Number C, carbon dioxide is formed when hydrocarbons are completely combusted. Number one, name the other product of the complete combustion of hydrocarbons. During combustion, we will always get water as one of the common product. So you'll write water here. Number two, the paraffin kerosene fraction from the fraction distillation of petroleum, crude oil contains hydrocarbons. State one use of the paraffin kerosene fraction. We know that kerosene is used in jets as jet fuel. So you'll write jet fuel or aircraft engines. Kerosene can also be used for heating and cooking purpose. So you can write heating, cooking. It's also used in lamps or in lighting purpose. Question number 3. The alkenes are a homologous series of hydrocarbons. A. Give the general formula for the alkenes. CnH2n will be the general formula for alkenes. B. The structure of an alkene is shown. This is the structure of an alkene. Part 1. Name this alkene. Now, alkene contains carbon-carbon double bond. If you look at the position of carbon-carbon double bond, it's the position number 1. Start counting the carbon atoms, and you will start counting from the carbon which contains carbon-carbon double bond. 1, 2, 3, 4. So you can write but1ene or butene. Number 2, explain how this structure shows that alkenes are unsaturated. Unsaturation means it has carbon-carbon double bond. So has carbon-carbon double bond. Hydrocarbons. Hydrocarbons are compounds which contain hydrogen and carbon only. Contains hydrogen and carbon only. C. Alkenes are produced by cracking some fractions obtained from the fractional distillation of petroleum, crude oil. State the meaning of the term cracking. Cracking means breakdown or decomposition. During cracking, we crack long chain alkanes to get smaller hydrocarbons. So you can even give the idea of breaking long chain hydrocarbons to get short chain alkanes. Idea of breaking long chain hydrocarbons. D. Carbon monoxide is formed when alkenes undergo incomplete combustion. State 1 effect of carbon monoxide on health. It's a poisonous or toxic gas. E. Alkenes react with bromine to form compounds containing carbon, hydrogen, and bromine. Number 1, a compound contains 22.2% carbon, 3.7% hydrogen, and 74.1% bromine by mass. Calculate the empirical formula of this compound. We need the AR or nucleon number of carbon, hydrogen, and bromine to carry out this calculation. So you'll write carbon, hydrogen, and bromine. For carbon, you have 22.2 divided by 12. For hydrogen, you have 3.7 divided by 1. Bromine should be 74.1 divided by 80. So for carbon, we will get 1.85. Hydrogen we will get 3.7. For bromine, we will get 74.1 divided by 80, 0.926. So which number is the least here, or which number of moles are the least here? It's 0.926. So we will divide all the values by 0.926. In case of carbon, we will get 1.85 divided by 0.926, 1.997, which will be equal to 2. So you write 2 here. For hydrogen, 3.7 divided by 0.926, 3.995, which means we can write 4. It will be round off to 4. For bromine, you will get 1. So the final empirical formula will be C2H4Br. Number 2, a different compound of carbon, hydrogen, and bromine has the empirical formula C3H2Br. The relative molecular mass of this compound is 236. Deduce the molecular formula of this compound. In order to calculate the molecular formula, we need to divide the molecular mass by the empirical formula mass. So empirical formula is given here. So first of all, I will calculate the empirical formula mass for C3H2Br. There are 3 atoms of carbon. So you will multiply 3 by 12, we get 36. There are 2 atoms of hydrogen. So we will multiply 2 by 1, we will get 2. 1 atom of bromine. So we will multiply 80 by 1, which will be 80. Now I will add up all these values. 36 plus 2 plus 80 will get 118. 118 is the empirical formula mass. Now we will divide the 236 by 118 to get the value of N. N is equal to 236 divided by 118. 236 divided by 118, you will get 2. So we'll multiply 2 by each number of atoms in this formula. 2 multiplied by C3H2Br. So final molecular formula would be C6H4Br2. Question number 4. This question is about ammonia and ammonium salts. A. Ammonia is manufactured by the Haber process. Number 1, name the catalyst used in the Haber process. This is very easy. You know the catalyst. This is iron. Number 2, explain how a catalyst increases the rate of reaction. It simply lowers the activation energy of the reaction. Lowers the activation energy of the reaction. B. Ammonium phosphate NH4 whole thrice PO4 is a fertilizer. Calculate the percentage by mass of nitrogen in ammonium phosphate. Give your answer to 3 significant figures. First of all, we need the MR of ammonium phosphate. So we have 3 atoms of nitrogen. So we'll multiply 3 by AR of nitrogen, which is 14. 3 multiplied by 14, 42. We have 12 atoms of hydrogen, because 4 multiplied by 3, we will get 12. So for hydrogen, 12 multiplied by 1 is equal to 12. Phosphorus, the nucleon number or AR of phosphorus is 31. 31 multiplied by 1, we will get 31. Oxygen, there are 4 atoms of oxygen. So we will multiply nucleon number of oxygen by 4. 16 multiplied by 4, we will get 64. So adding up these together, 42, 12, 31, and 64. 9, 4 plus 1, 5, 5 plus 3, 8, 8 plus 6, 14. So 149 will be the MR of this compound. Now I want to calculate the percentage by mass of nitrogen here. So we have 42 as the mass of nitrogen in this. So we will multiply 42 by 100 and divide the answer obtained by 149. 42 multiplied by 100 divided by 149. 28.187. 28.187. Or you can even write 28.2. Fertilizers can make soil more acidic. Number 1, state the name of a compound used to decrease the acidity of a soil. You can use alkali or basic oxide for this purpose. So you can write calcium hydroxide, or calcium oxide. To explain how this compound decreases the acidity of the soil. It's very easy, simply neutralizes the acid. (4D). Ammonia is formed by the reduction of nitrogen monoxide N2O with hydrogen. The reaction is exothermic. This is the reaction. N2O plus 4H2 gives 2NH3 plus H2O. Complete and label the energy profile diagram for this reaction to include the reactants and products, the enthalpy change of the reaction. The reaction is exothermic, so the product will be on the lower energy state. So if this is the reactant, so we'll have energy hump, and this will be for the product. Now I'm writing the symbols for reactants and products. Reactant is N2O plus 4H2. The product side, you have 2NH3 plus H2O. Now in the question, they have asked to show the enthalpy change of this reaction. Enthalpy change is between reactants and products. We have reactants and products here. This will be the enthalpy change. Part E, copper 2 oxide CuO reacts with ammonia. The products are copper, nitrogen, and a liquid which turns blue cobalt 2 chloride paper pink. Construct the equation for this reaction. Formula of copper 2 oxide is CuO. So I will write CuO. For ammonia, it's NH3. Now the formula of the products obtained for copper, CuO, nitrogen is N2. And they are saying a liquid which turns blue cobalt 2 chloride paper pink. It's water. This is the test for anhydrous cobalt 2 chloride, H2O. Now let's balance the equation. You see on the left hand side, you have 1 mole of copper 2 oxide. There are 1 atom of copper. Copper is balanced. What about oxygen? Oxygen is also balanced. Nitrogen is not balanced. It's N2 on the product side. So I will write 2 before ammonia. This will make 6 moles of hydrogen. 2 multiplied by 3 is 6. So I have to write 3 here before H2O. Now the number of moles of oxygen becomes 3. So I can write 3 before CO to balance oxygen. This makes 3 moles of copper. So I will write 3 on the product side. Now this equation is balanced. Question number 5. This question is about metals and metal compounds. A. Magnesium reacts with aqueous iron 2 ions. This is the reaction. Mg plus Fe2 plus gives Mg2 plus Fe. Explain why this reaction involves both oxidation and reduction. Use the equation and ideas about electron transfer in your answer. Whenever they talk about electron transfer, you will refer gain or loss of electrons. So in this equation, magnesium loses electrons. Magnesium loses electrons. You can see it because it has acquired +2 charge or 2 plus charge. So it is oxidation. Oxidation is the loss of electron and reduction is the gain of electron, which means that iron 2 plus has gained electron and it is reduction. So you will write iron 2 ions. Iron 2 ions gain electrons and it is reduction. B. Explain why iron conducts electricity. It's very simple. Electrons can move throughout the structure. C. Explain why magnesium is extracted by electrolysis and not by reduction with carbon. So electrolytic method is preferred when the metal is highly reactive. So you write it's highly reactive. Or you can even refer the position of magnesium in the reactivity series. Magnesium is high in the reactivity series. D. Describe a chemical test to distinguish between aqueous iron 2 ions and aqueous iron 3 ions. So you can refer any of these tests either with aqueous sodium hydroxide or aqueous ammonia. So you write add aqueous sodium hydroxide or aqueous ammonia. Iron 2 ions always give green precipitates. And iron 3 ions gives reddish brown or red brown precipitates. E. Number 1. Explain why molten magnesium chloride conducts electricity. Magnesium chloride is an ionic compound. And ionic compounds conduct electricity either in the molten state or when dissolved in water. And there's only one reason: whenever their ions become free. So you write ions can move or ions are mobile. Ions are mobile or can move. Number 2, predict the products formed at the anode and the cathode when molten magnesium chloride is electrolyzed. Whenever magnesium chloride in the molten state is electrolyzed, you will get two products. At cathode, chloride ion will lose electron and chlorine will be produced. Chlorine or Cl2. On the cathode, magnesium ion will gain electron and produces magnesium or Mg. F. Food containers can be made from aluminium. State one property of aluminium that makes it suitable for use as a food container. So it must be related to its reactivity. So you can write it's unreactive. You can also write it does not react or corrode in air. Does not corrode in air or even with water. Section B. Answer 3 questions from this section in the spaces provided. The total mark for this section is 30. Number 6, this question is about compounds of nitrogen. A. The equation represents the equilibrium between N2O4 and NO2 at a high temperature in a closed container. This is the reaction. N2O4 gas gives 2NO2G. This is a reversible sign. Number 1, predict what happens to the position of equilibrium when the pressure is decreased. Explain your answer. You know that whenever pressure is decreased, the equilibrium will shift towards the side with high number of moles or volume of gases. So if you look at this equation, we have high number of moles or volume of gases on the right hand side or the product side. So equilibrium shift to the right hand side. Equilibrium will shift to product side, product or right hand side. Now, what will be the explanation? You can refer the number of moles or volume of gases on any side. High number of moles or volumes of gases on right hand side, or less number of moles or volume of gas on left hand or reactant side. Number two, the table shows the concentration of NO2 in the closed container at three different temperatures. So temperatures given on the left hand side of this table. See 100 degrees centigrade, 150 degrees centigrade, and 200 degrees centigrade. So what's happening with the concentration of NO2? You see it's increasing. It's 0.04, 0.4, and 4. State what this information shows about the enthalpy change of the forward reaction. Explain your answer. Enthalpy change. The reaction is, I'm writing the equation again for your convenience, N2O4 to NO2. So you have high concentration of NO2 when the temperature is increased. So delta H must be positive in the forward direction. Delta H is positive. So you can write enthalpy change. The reaction is endothermic. Then you can refer to the concentration of either NO2 or N2O4 at different temperature. For instance, if you want to write for NO2, you can write because concentration of NO2 increases, the concentration of NO2 is high at high temperature. Or the concentration of N2O4 is low at high temperature. B. Nitrogen dioxide NO2 is made by heating lead to nitrate PbNO3 whole twice. The other products are lead 2 oxide and a gas which relights a glowing splint. Number 1. Construct the equation for this reaction. The formula PbNO3 whole twice will be on the reactant side. PbNO3 whole twice gives lead 2 oxide should be PbO. Lead 2 means lead, the charge on lead is +2. Oxygen belongs to group 6. So the charge on oxygen is -2. Ignoring their charges, these will be simplified. Subscript will be exchanged and you will get PbO plus a gas nitrogen dioxide is produced and a gas produced which relights a glowing splint and which is oxygen. Now let's balance this chemical reaction. Let's count the number of atoms on each side of the reaction. Pb is 1 on both sides of the equation and is 2 on left hand side, but on right hand side it's 1. What about oxygen? Oxygen is 6 on the left hand side and on the right hand side it is 1, 2, 3, 4, 5. It is 5. So if we will start by balancing oxygen atom, so we have to balance the other elements also. So in case if I will change the number of moles for PbO, I'll write 2 here. So this reactant will also become 2. Now you can start counting the atoms. There will be 2 multiplied by 2, 4 moles of nitrogen or 4 atoms of nitrogen on the product side. What about oxygen? 2, 3, 2 multiplied by 3, 6, 6 multiplied by 2, 12. Should be 12. So in PbO, there are 2 atoms of oxygen and in NO2, there are 8 atoms. 8 plus 2 is 10 and 10 plus 2 is 12. It's balanced now. Number 2, nitrogen dioxide contributes to acid rain. State one effect of acid rain on organisms. So you can write deforestation or kill plants. Deforestation or kill plants. You can write trees also. Kill aquatic organisms. Kill aquatic organisms. C. Nitric acid HNO3 is a strong acid. Number 1, state the meaning of the term strong in strong acid. Strong means dissociate, break up, ionizes, completely in solution. Dissociates or ionizes completely in aqueous solution. Can even refer solution. No need to write aqueous. Number 2, suggest a pH value for a concentrated solution of a strong acid. The pH value should be from 0 to 2 for any strong acids. Complete the ionic equation for the reaction of an acid with an alkali. The equation is H positive plus OH negative and water will be the product. H2 will be the product. So you write OH negative here. Number 7, this question is about alcohols and polymers. A, the structure of an organic compound is shown. This is the structure of an organic compound. Deduce a molecular formula of this compound. So we'll start counting the atoms. We'll start with carbon. 1, 2, 3, 4. So you write C4. Now start counting hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen atom 1, 2. So this will be the molecular formula of this compound C4H8O2. B. An isomer of butanol has the structure shown. This is the isomer of butanol. Number 1, state the meaning of the term isomerism. Compound with the same molecular formula but with different structures or structural formula. Compounds with same molecular formula but different structural formula. You can even refer arrangement of atoms. Remember, you have to write compounds with different molecular formula. Never write molecules. Although you know that compounds are also molecules, but molecules mean you can even have molecule of elements. So never write molecules. Number 2, draw the structure of a different isomer of butanol. The one which is given has OH attached to carbon number 1. You can change the position of OH to either 2 or 3rd position, not at 4th position. Not at this point. Neither 1 or 4th position. So you can have any of these positions, 3 or 2. So these are the isomers of butanol. 1, 2, 3, 4. I'm placing OH first, then I will place hydrogen atoms to each carbon atoms. The other possibility will be this. So both of these are correct. You can draw any one of these. If you start counting the carbon atom on either side, 1, 2, 3, 4. You see, in the first one, you have OH attached to second carbon atom. In the second one, 1, 2, 3, 4. It's attached to third carbon atom. You can even start counting from left-hand side. 1, 2, 3, 4. And the first structure, 1, 2, 3, 4. So you can draw any one of these for the isomer of butanol. 3. Butanol reacts with ethanoic acid CH3COOH to form an ester. Name this ester. Draw the structure of this ester. Show all of the atoms and all of the bonds. What will be the name of ester? When the alcohol is butanol and the carboxylic acid is ethanoic acid. Butanol plus ethanoic acid. Remember, the alkyl group comes from the alcohol. So you'll have butyl. and alkanoid will comes from ethanoic acid. Alkanoid, it's alkyl. So alkanoid will be ethanoid. Ethanoid. So you can start drawing the structure. We have butyl group. Group will be 1, 2, 3, 4. And for butyl group, it must be having oxygen attached. Now you have alkanoid group, which is ethanoid here. So you have carbon 1, 2. Ethanoid means 2 carbon atoms. Now I'm placing the hydrogen atoms. This is one way of drawing butyl ethanoid. Now I will show you the other way of drawing this butyl ethanoid. You can start with the ethanoid side. 1, 2. Oxygen. Now for butyl group 1, 2, 3, 4. Now I am placing the hydrogen atoms. So both of these displayed formula are correct. You can draw any one of these. C. The partial structure of a polyester is shown. Draw the structures of the two monomers used to make this polyester. First of all, you have to look at the repeating groups in this polyester. One is the repeating unit here. The other one will be here. Now I'm drawing the repeating units. C double bond O. CH2 hold 6. C double bond O. It must have OH. And for the other repeating unit, O bond CH2 hold 6 O. You can attach it with H. So this will be the other repeating unit. D. Terylene is a polyester. State one use of terylene. Terylene is commonly used in clothing. So you write clothing. Name a naturally occurring molecule which has the same ester linkage as terylene. We know that's fat, so you write fat. Record the ester linkage. Ester linkage is this: C double bond O. E. Starch is a polymer which can be hydrolyzed. State the meaning of the term hydrolysis. Hydrolysis means breaking down of a substance by water, acid, or alkali. Breakdown of a substance by water, acid, or alkali. You can even refer the ions for acid H positive, alkali it's OH negative. Eight. This question is about metals and metal compounds. A. Brass is an alloy of copper and zinc. Brass is less malleable than either copper or zinc. Explained with reference to the structure of metals why brass is less malleable than either copper or zinc. You may include a labeled diagram in your answer. So in brass, it's a mixture of metals. Alloy means some mixture. So brass is an alloy of copper and zinc, which means that it contains both the atoms of zinc and copper. Now in this question, they are asking to compare in terms of malleability, that why brass is less malleable than copper or zinc. You have to refer to the structure. Remember, in case of alloy, there are large atoms of metal which prevents the small size metal atoms from sliding over one another. So if you want to draw the diagram will be like this. These will be small atoms. This is large size atom, and these are the small atoms. So these are small metal atoms. This one is large metal atom. So what you will write in the answer? You have to compare with the pure metal. In pure metal, metals or ions can slide. In pure metals, the atoms or ions slide or slip over one another. In case of alloys, large sized metal atoms prevent the small sized metal atoms from sliding over one another. The table shows the reactivity of four metals with cold water and with steam. These are the metals: chromium, mercury, potassium, and uranium. And this is their reactive behavior against cold water and with steam. Put the four metals in order of increasing reactivity. You have to put this in the order of increasing reactivity. So if you look at this table, mercury is the one does not react either with cold water or with steam. So we'll start with mercury. The next one must be chromium, because it's reacting slowly with steam and it's not reacting with cold water. So you write chromium. Now we are left with potassium and uranium. Potassium is reacting very fast and explosively, very fast with cold water and explosively with steam. And uranium is reacting slowly with cold water and reacting slowly with steam. So you'll write uranium here. And the most reacting one will be the potassium. See, the full symbol of an ion of mercury is shown. This is the full symbol for mercury ion, Hg2 plus. Reduce the number of electrons and neutrons in this ion. So 2 plus mean it has lost 2 electrons. So you will subtract 2 from 80. 80 minus 2, you will get 78. So the number of electrons will be 78. What about the number of neutrons? You have to subtract 80 from 199. 199 minus 80. And you will get 119. Yeah, I'll do the calculation. 199 minus 80, 119. The formula of chromium 3 sulfate crystals is Cr2SO4.18H2O. State the name given to the water present in Cr2SO4 whole thrice .18H2O. So whenever water is attached to a salt, we call it water of crystallization. Water of crystallization. E1, aqueous bromine reacts with aqueous potassium iodide. The products of the reaction are aqueous iodine and aqueous potassium bromide. Construct the ionic equation, including state symbols for this reaction. So the reaction will be like this: Vr2 plus Ki gives KBr plus I2. Now let me balance the equation. This is the balance equation. So what you'll do, you remove the common ions from the both side of the equation. So the common ions will be cancelled out. We have potassium ion being the common. So we have Br2 plus I must carry minus charge. So you write 2I minus gives here on the product side, Br must carry minus charge to 2Br minus plus I2. Explain in terms of the reactivity of halogens why aqueous iodine does not react with aqueous potassium bromide. You can refer to the reactivity either the position of iodine. Iodine less reactive than bromine, or it is below bromine. Number 9A, zinc powder reacts with dilute hydrochloric acid. This is the reaction between zinc and hydrochloric acid. Zn plus 2HCl gives ZnCl2 plus H2. When 20 centimeter cube of dilute hydrochloric acid is added to excess zinc, the volume of hydrogen gas produced at room temperature and pressure is 60 centimeter cube. Calculate the concentration in mole per dm cube of the dilute hydrochloric acid. So first of all, we need the moles of hydrochloric acid. In order to get the moles of hydrochloric acid, we need the moles of gas hydrogen produced, which is 60 centimeter cube. You know that at RTP, for 1 mole of any gas, 1 mole of any gas at RTP, that is room temperature pressure, occupies 24,000 centimeter cube. So what will be the mole for 60 centimeter cube? What we will do, we will divide 60 by 24,000. 0.0025 moles of hydrogen. And looking according to the equation, H2 HCl, 1 mole produced by 2 moles of HCl. So 0.0025 moles produces X moles. So which will become X is equal to 2 multiplied by 0.0025. 2 multiplied by 0.0025. 0.005 moles of hydrochloric acid or HCl. Now volume is given. If 0.005 moles is present in 20 centimeter cube, so how many moles in 1000 centimeter cube? 20 centimeter cube contains 0.005 moles. 1000 centimeter cube contains X moles. So it will be 1000 multiplied by 0.005 divided by 20, 0.25. So answer will be 0.25 moles per dm cube of hydrochloric acid. The reaction is repeated using large pieces of zinc instead of zinc powder. All other conditions stay the same. Describe how the rate of reaction changes. Explain your answer using ideas about collisions between particles. So remember, the rate of reaction will decrease. The reason is that in large pieces, the surface area of the particles will decrease. So you write rate of reaction will decrease. Further, what you write, then fewer particles will be exposed. Fewer particles exposed on the surface because the size of the particle is increased and the frequency of collision also decreases. Frequency of collision decreases. B. Dilute hydrochloric acid is electrolyzed, construct an ionic equation for the reaction at the cathode. So at the cathode, the hydrogen ion will move towards cathode and will take up the electrons to form H2 gas. So you will have H positive plus electrons, H2 gas produced. A balanced equation will have 2H and 2 electrons. Zinc is used to prevent iron from rusting. Number one, state the essential conditions needed for rusting. For rusting, it's important. Water and oxygen must be there. So you write water and oxygen. If any one of these is missing, rusting will not take place. Number two, explain how zinc prevents iron from rusting by the method of sacrificial protection. Zinc reacts or corrodes in preference to iron because zinc is above iron in the reactivity series. So you can also write zinc is more reactive than iron. Number three, give one example of the use of sacrificial protection. They are asking about the uses or application of sacrificial protection. Underground pipes will be stopped from corrosion. So you can write stops underground pipes from corrosion. You can also write this stops ship hulls from corrosion. Stops ship hulls from corrosion. Thanks for watching. Press like and share my videos, give comments. For more videos, subscribe to my channel and press the bell icon.